Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. After learning the conjugate of complex number, we need to learn few properties of conjugate number, which are very important. You must understand, you must learn, you must know those properties of conjugate number, all right? For that, let me take an example of a complex number. Let's say Z is a complex number which is A plus IB. I means iota here. And similarly, let me imagine one more complex number. Let's say W is equals to C plus ID. All right, so the first thing I want to tell you here, the real part of the conjugate number Z, all right, is 1 over 2 Z plus the conjugate of Z, all right? So if you want to find out the real part of a complex number, then it's just the half of the sum of the complex number and the conjugate of that. All right, this is the conjugate of that complex number. This was the first one, and similarly, if you want to find out the imaginary part of the complex number, then it is again half of the difference of the complex number and the conjugate of that. The complex number is A plus IB, all right, and minus the conjugate of that is A minus IB, but it is inside the bracket, all right? Okay, so I'm going to open the bracket. It's A plus I times B, and now minus A and minus times minus, this will give you the plus IB, okay? And then this A and this A will cancel up, and you'll get 1 over 2 times now IB plus IB, it's twice of IB. This 2 and 2 will cancel up, and you'll get IB. So from here, it is very clear that the real part of the complex number is equals to the half of the sum of the complex number and the conjugate of that. And similarly, the difference of the complex number and the conjugate of that, if you do the half of that, you'll get the imaginary part of that particular complex number. So this is a little rule of the conjugate of the complex number, all right? And the next properties is if you add two complex number and then you find the conjugate of that, then that is equals to the individual sum of the conjugate of those two numbers, all right?
If you add two complex number and then you find out the conjugate of that, then it seems like finding out the conjugate of each and adding it. All right, let me show you how it is. All right, let me give the proof of this. Let me first add the complex number Z, and so is A plus IB. And similarly, W is C plus ID. And whenever we add the two conjugative number, you know very well that we add the real parts, we put the real parts together, and then we put the imaginary parts together. All right. So it's going to be now B plus T. And our left hand side is here, our left hand side is here, Z plus W bar. All right. So it's simply A plus C. Now, whenever you find the conjugate of that, is just the sign get changed. So it's minus B plus D. All right, and I will be here. Okay, so now further what I'm going to do, I'm going to write A plus C. All right, I'm going to multiply by this minus I to both of them. So it's going to be minus IB and then minus plus minus I times D. So further it's going to be A. I am now writing these two together, this A and I together. So it's going to be minus I, oh no. Okay, minus IB, I write these two together. And now next time I'm writing these two guys together. Okay, so it's going to be now this plus C minus ID. See, I didn't do anything. It's plus A is here, and minus IB is here, plus C is here, minus ID is here. And now you know what it is. I'm just going to make the bracket over here, and A minus IB is the conjugate of Z. All right. Similarly, C minus ID is IC is the conjugate of yes W. So what's that? So Z plus W bar, that is the conjugate of sum of the Z and W complex number, is equals to the individual sum of the conjugate of Z and W. All right. That's our right hand side. This is proved. All right. So this was our second properties of the conjugate. Conjugate of the product of the two complex number is equals to the product of the individual conjugate of those complex number. All right. So here, let me show you first Z times W. Let me first find, and then I will show you how it is equals to the individual product of them. All right. So Z is our A plus IB and W is our C plus ID. So when you multiply two complex number, it's going to be x1, x2 minus y1, y2. So it's AC minus BD. All right, plus x1 y2. I mean, first let's write I, x1 y2, that is AD, or you can say the terminal parts, and times the plus the middle parts plus BC. This is the simply multiplication of the two complex number. I hope you remember this. First it's like x1 x2 minus y1 y2. I mean x1 x2 minus y1 y2, and then plus I, and then the terminal parts plus the middle parts. All right, including the I. This is the product. All right, I know you are very smart in finding out the product. So now I'm going to find out the conjugate of this new complex number
that we recently find after the multiplying z complex number by w, or you can see the product of the complex number z and w. So simply the conjugate of this is ac minus bd as it is, and the sign just get changed. You know that. So it's minus I ad plus bc. Okay, so further I'm doing AC minus BD, and I'm doing a little thing here because in the multiplication formula minus do not come, so I'm trying to make it plus, and by doing so what I'm doing here, I have to bring this minus inside this. So I'm writing A times minus D, and again plus C times minus B. And I think you understand this, how I did it. It's AC minus BD as it is, as it is. And I took minus common, so minus will multiply this time here also will be 1 minus, and here also will be also 1 minus. So A is positive, but the product D is negative, right? And this minus will be here, so I just brought that minus into the B format. And now if you compare the product of the two complex with the standard formula, what is our standard formula of the product of the two complex? Isn't this like x1 x2 minus y1 y2, which is exactly matching? This is x1, this is x2, this is y1, this is y2, plus I times x1 y2 plus x2 y1. So see here, x1 as it is, y2 is in the negative format, and x2 is positive, and y1 is negative. All right, and AC here both are positive, A and C both are positive, so it is positive. All right, and B is here negative. See here, B is here negative. All right, this has also one negative, and D has also one negative. So minus minus, when they multiply, minus times minus, you'll get plus. All right, so here no problem with the sign. All right, so this is exactly with the standard formula, and this is a multiplication of the two complex number, A plus I times minus B. All right, this is one complex number times C plus I times minus D. All right, if you do the multiplication of these two complex numbers, then you'll exactly get this. You can check it up. All right, let's see, x1 x2 minus y1 y2. All right, so A times C, which is here, minus y1 y2, that is minus B times minus, plus, so you'll get plus B, and in the middle you'll get minus from the formula. It's right. You can do also, right, you can practice. If you do not understand, you just multiply manually these two, you'll definitely get this. All right. And what is this? This is simply A minus IB, and this is simply C minus ID. And A minus IB is a conjugate of Z, and C minus ID is a conjugate of W. So what do you get? You get dot W conjugate is equals to conjugate of Z times conjugate of W. So here is proved. All right, and now the fourth properties of the conjugate of a complex number you have to understand is if you do twice the conjugate of a single number, then you'll get the same complex number. All right, you have a complex number and you do the twice conjugate of that, then you'll get the same, here the first z is A plus I. So the first conjugate is definitely A minus I. And now you're going to find out the conjugate of this j bar, or bar j. So conjugate of this j bar will be one more bar over here. So it'll be A, and just opposite of the sign and opposite of the minus is plus IB, and which is this one. That's why I'm saying this is z. All right, so if you do twice the conjugate of a number, then you'll get the same number. And the fifth properties of the conjugate of complex number is if you multiply the complex number with the conjugate of that, then you're going to get a real number. You'll get a real number, Let me show you how. Here is jed times bar jed. Okay, jed is here, a plus ib, and the conjugate of this will be just opposite in sign, a minus ib. And if you simply look without multiplying, I will simply say, isn't this a plus b, a minus b? Like, a plus b, a minus b, the algebraic form for the a plus b, a minus b is a squared minus b squared. So what I'm going to do now here, a squared minus ib whole squared. So what are you going to get? You're going to get a squared minus, now it is I squared b squared. It's a squared, and the value of I squared is -1. So it's -1 times b squared. So you're going to get a squared plus b squared, which is a real value, which is a real number. So from here, what did you understand? That whenever you multiply a complex number with the conjugate of that, then you are going to get a real value. Keep in mind that this is a little important. Right. Thank you so much for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.